Welcome to Saturday CI Barcelona. Today we invited to Dídac Fortuny. He works as data scientist at Adevinta, and he will present a deep learning solution to improve matchmaking in InfoJobs.
Well, yes, my name is Dídac Fortuny. I am a member of the machine learning team in InfoJobs, that is part of Adevinta, and I will talk today about how we use deep learning to improve the matchmaking in our site. But first of all, my talk at the beginning, I will explain who I am and why I'm here, and then I will go from the beginning to the end of the solution that we have made, from building the ground truth until putting this into production, to show how we can use deep learning to solve real problems. And at the end, I will show some of the use cases of our normalization model. First, I did my PhD in the University of Barcelona. I did a PhD in climate change, and then after that, I decided that I didn't want to spend more time doing research. So I moved into the data science world, and I started working as a data scientist in Hora, in which my team mostly used machine learning to predict the consumption of electricity and gas of our customers. Then I also collaborated with News UK, the company behind the Times and the Sun and other British newspapers. And in here we built a prototype based on machine learning to predict whether the articles on their website would be successful or not based on different characteristics. Then I also worked in Delivery Mates. It's another British company that manages a crew of drivers for delivering food and other kind of things. And in here, what we did is optimize routes and also predicting the time in which the food will be ready in the restaurant to optimize the entire workflow. And finally, I started working in Schibsted, that now is called Adevinta. That is a Norwegian company behind a lot of marketplaces like InfoJobs, Habitaclia, Fotocasas, Coches.net, Milanuncios. In particular, I am working in InfoJobs. And then, apart from my work, I also collaborate with VCN Analytics, that is like an association of people who want to promote the use of analytics and data in the Barcelona area. We organize meetups about different topics related with machine learning and other data fields. And also, we organize from time to time some datathons. For example, 2 years ago, we organized a datathon about air quality in Barcelona with the Barcelona Supercomputing Center. And finally, I am also involved in Data for Good Barcelona. I will explain a bit more what this initiative is. Data for Good Barcelona is a non-profit organization that wants to promote the usage of data for social purposes. We are following the steps of other initiatives that already are working in Europe, like DataKind in the UK, or Data for Good that already exists in France. We are now starting this in the Barcelona area. And mainly what we do is to put in contact NGOs and other social organizations with data professionals who has some social, they want to contribute to society, so we put them together to work together. We have already worked with Médicos Sin Fronteras, Doctors Without Borders, and with FADA, an NGO that helps animals. In fact, Jordi was one of the members of our team in FADA. And we are now starting to work with many other associations. So if you are interested in this, you can contact me later and maybe you can help us. Also, we want to become a speaker for all the social initiatives related with data that happen around us, that there are a lot, so we want to promote them. And finally, we organize meetups for showing how it is possible to use data not only for gaining money, but also for helping society. In fact, you are all invited to our next event that will be on 9th March in 2 or 3 weeks. If you want to know more about this initiative, you can look us in the net. We have a Twitter account, we have a website, and you can join our newsletter. If you look for Data for Good Barcelona in Google, you will find everything. But I'm not here to talk about Data for Good. I'm here to talk about the deep learning solution that we have in InfoJobs, so I will start the proper talk. First, I assume that most of you know what is deep learning. Deep learning is like a subfield of machine learning that is mainly built using deep neural nets. I will put some examples during the presentation, but it's just a subfield of machine learning. I don't know if you are familiar with what it is matchmaking, or sometimes it's called matching. So let's start defining what is matchmaking. In Adevinta, we mainly do matchmaking. Matchmaking is finding the best house for each family who wants to buy a car in Habitacle or Fotocasa, finding the best car for each buyer in coches.net. In InfoJobs, matchmaking is finding for each employer who publish a job offer the best candidate for the position, or the other way around, finding for each person who is looking for a job, finding the best job for them. But what we found is that sometimes the people that use InfoJobs have some sort of troubles. For example, this man here, who is a recruiter and who was struggling because he was looking for Python developers, and even though he was using InfoJobs, and in InfoJobs we have plenty of people who can work as Python developer, because they didn't write in the job title field that is here under the name exactly Python developer, the recruiter couldn't find them easily. And we found another problem. People who is, for example, this girl here who is a Python developer, who was looking for a job and who couldn't find a job, even though she was using InfoJobs, because and in InfoJobs there are a lot of offers or companies that are looking for someone to program in Python. We can see here, but the exact words Python developer are not written here. So the matchmaking was not direct to do. So we formulated this hypothesis. If we are able to normalize the job title field of both offers and resume entries, we can improve the matchmaking and improve the life of both candidates and recruiters. And what it is normalizing? For us, normalizing means given a closed list of job title categories, what we call a taxonomy. These are a closed list of classes. Normalizing is finding that each job offer or each resume entry, finding which class do they belong. So for example, the first one, this man here who considers himself a dog whisperer, if we normalize this job title, we can tell that corresponds to the fourth class that he is hearing dog instructor, based on all the information that he has given to us. Or this offer that is looking for a coordinadora de tráfico urbano, we can also normalize into traffic coordinator based on all the information we have in the entry. So based on this, the approach that we followed to solve the problem was designing a model exactly for doing this. Given each job offer or resume entry, normalize into one job title category with a confidence score to see whether we can trust the model or not. For example, this man here, if we have a proper model, we could normalize the resume entry into the class 1263, that is the one including all the Python developers. And we could normalize also this offer to the same class, so we would do the matching. Now I will explain in detail how we build a model, how we have the data, and how we evaluate whether the model is working correctly or not. And for training any model, what you need is data. And what you need is labeled data. And this is what is called the ground truth. The ground truth is nothing more than a lot of observations and examples, in our case of offers and resume entries, in which we know for each one to which class it belongs. But first we need to create this ground truth, we need a taxonomy, the closed list of job title categories. Sometimes you have it, but most of the times having the taxonomy is one of the problems that you face, because you want to normalize something, but you don't know the classes to which you want to normalize. In our case, we took an European standard called ESCO, because it contains a whole hierarchy of job titles, so we can group them into different levels of granularity. Here we would have very detailed job titles, and here we have very wide job titles. It also helps us. And it's also a huge taxonomy with about 3,000 occupations. And also because it is maintained by the European Union, it's available in several languages. This is also useful for us because InfoJobs is mainly in Spanish, but some people write in English, and also InfoJobs exists in other countries. So with this, we can have the same category and include all the synonyms and all the words in all the languages. Also, it is well maintained. If new occupations appear, they will be in ESCO. If we use ESCO, we can get them. For example, in some years, maybe people will start looking for influencers or YouTubers. These new professions will be here as well. And also contains a lot of synonyms with all the, as you will see now, with all the names and synonyms, we have about 50,000 job titles. So our taxonomy looks like this. We have class 1, and the one with the construction laborers, and all the synonyms here. That is other ways of saying the same thing, and also translations, and also, this is also important in Spanish, the male and the female way of writing the job title. With this, we have about 3,000 categories. And the other thing you need to build the ground truth, once you know the classes to which you want to classify, is a set of labeled examples. And this, to build one model, you need a lot of labeled data in order to train the model properly. So if you want to do it manually, you will spend a lot of time telling which thing is which. So you have to find approximations or tricks to find labeled data easily. What we did was, first, we found the direct matches. So if we have someone who says that is an adiestrador de perros guía, and we know that adiestrador de perros guía is one of the synonyms of the class number 4, we can tell that this belongs to class 4. This goes directly to our ground truth. This one as well. This offer is looking for a construction laborer, because this, we know that the exact string in our taxonomy, we can label this directly. If someone writes here something that it is not in the taxonomy, for the moment we don't use it in our ground truth because we don't know the correct prediction. With this, we built a preliminary ground truth, and we trained a preliminary classifier model. Later I will explain how the model works. With this preliminary model, what we did is we did predictions for these offers and resume entries that didn't have an exact name belonging to our taxonomy. So we predicted for new observations, and with manual labeling, here we hired someone to check the predictions of our preliminary model and to tell whether they were correct or not. We built an extended ground truth, and with this we trained a final classifier model that is the one that we put into production. And I will now explain the insights of our deep learning model based on deep learning. And the idea behind our model is transfer learning. I don't know if you are familiar with transfer learning. Someone has heard about it? Yeah? Okay. For those who haven't, transfer learning means learning to solve one problem and use the knowledge that you have gained to solve a similar but slightly different problem. For example, if you at school learn how to write compositions, then when you are an adult, you don't use that knowledge to write compositions. We don't write compositions anymore. We use it for writing books, for writing emails, for writing letters. So we learn to solve one problem, but all we gained for learning how to solve one problem, we use it for another but slightly different problem. Transfer learning has been widely used in computer vision. For example, if you want to build a model to predict whether this face here belongs to a female or to a male, you can build a deep convolutional neural network. And if you look at the different layers of the model, you will see that the first layers learn how to recognize patterns or shades or very simple structures. As you go deeper, the model is able to recognize more complex structures like eyes, noses, and then at the end, the last layers of the model are able already to locate where is the face in the image and these more complex structures. And then at the end, you only need some classifier layers to tell whether what the model has learned belongs to a female or a male. If you now want to build a model to classify whether the image belongs to one of these 5 persons here, you don't need to train from scratch a model and give a lot of images from them to tell this. Everything that is inside the orange box, you can reuse it because the model has already learned how to locate the face and to tell which parts of the face are important. So you only need to give the model train a little bit further with images of the new people because the model has to know how they look. And then change the last part of the model because mainly before we were predicting into 2 classes and now we are predicting into 5 classes, so you need to change the last part of the architecture, but you don't need to train the whole model from scratch. You can reuse most of it. In natural language processing, we do something similar. We start with a general language model that is a model that has been trained to predict the next word in a sentence. Mainly these models are trained with large corpus of text like Wikipedia or other sources of text, and they learn how to predict the next word in a sequence. This is what is called a language model. Then we train a little bit further with text from InfoJobs because we want the model to learn how job offers and resume entries, the vocabulary that they use, that is mostly normal language, but sometimes they have some tricky words or some tricky expressions. And with this, we also train the same model, but a little further with using text from InfoJobs, also to predict the next word in a sentence. And with this, we already have a language model that is useful for us because it has been trained with InfoJobs data. This, we can almost download the model from internet because there are a lot of language models already trained out there. We fine-tune it with InfoJobs data, and we can use this model for a lot of things. We can use it, as I will explain now, for normalizing job titles or other fields, or also we can use it for doing sentiment analysis in the reviews of our users or everything. We have a model that knows the language that our users use. In our case, for the normalizing problem, at the end we plug these classifier layers that what we do is take all the information contained in the job offer or the resume entry and predicts to each of the job title classes of our taxonomy it belongs with a percentage of confidence, and then returns the one with the more confidence and with the score that is the probability that the entry belongs to that class. And if you want to know how the model is inside, mainly it consists on three recurrent neural networks, long, short-term memory neural networks. Then we have, we use a vocabulary size of 60,000 words and with an embedding size of 400 dimensions. And at the end, the classifier layers consist on fully connected layers with this number of cells here. To implement this, we have used FastAI, the library that they provide, because it's fast to, as the name indicates, it's fast for experimenting and prototyping. Also, it's easy to implement. They already give you all the classes that you need for building the model. And also, it includes state-of-the-art NLP techniques. For example, when the transformers started to be popular in natural language processing, they included very fast them, so we could start trying them without having to code for ourselves from the scratch all the architecture of the neural net. And then now I will explain how we implement this and how we use this into production. So each time when we have our model, we train the model and we have a pickle file that the Python code has produced or another type of Python file. What do we do with this? So each time a new entry enters our system, because a company is posting a job offer or some of you are updating your profile, the entry creates an event that is sent to Kafka. This event is listened by the normalization microservice, and this microservice calls the microservice containing the Python language model. This makes the normalization. The normalization is sent back to the normalization microservice, and this publishes another event that is also heard from Kafka. And all the products that use the normalization listen to this event and can use these normalizations. Well, if you have questions here, I cannot help you a lot because this is done by the backends of our team, but more or less this is the structure. And everything here is coded in Java and the Netflix stack, except the machine learning, the deep learning model that is built in Python. So this microservice here is an hybrid between Java and Python. And finally, I will explain how we know whether the model works or not. So we have our taxonomy, our list of job title categories here. When we want to evaluate the model, we take one entry. For example, this man here, Ethan Lee, he is considered himself a confitero, and the model classifies it into the category 0023. If we go to the taxonomy, we see that the category is this one with all these synonyms. Because the person has written in the job title part of the resume one of the synonyms of the category in which it has been normalized, we consider it a correct prediction. We count it as one. For example, this offer here is looking for a cocinero. The model has normalized this into the category 0023. It's the same one than before. But cocinero is a synonym of another category. So the model, if it was a good model, it should have normalized this into this category here. So we count this as a path prediction. And finally, if this alien here writes cake master, and we normalize also to the first category, in this case, because cake master is not in any of the classes of our taxonomy, we cannot know. So we don't use this type of predictions to evaluate our model. We only use these ones to evaluate our model. This is not perfect, but this is what we can do to tell whether the model is good or not. So with this, we built a dashboard. And the dashboard consists mainly of, we have a list of all the classes, all the categories, and we, with the technique that I just explained, we count how many trues, good predictions, and how many bad predictions we have. So we can focus on those classes that have more wrong predictions. And if we find this, we find that the class Rockstar, and this is fake data, by the way, the fake Rockstar has a lot of bad predictions. We can expand the ground truth, giving the model more examples of Rockstars to help the model to classify them better. And also, if we can, with our dashboard, we can focus on one category and zoom in and see which job titles introduced by people has been normalized to this, and also check whether there is something that is wrong here. And we can also do the other way around. We see that all the people that has written IT engineer in their resume has been, we can see where, in which category has been normalized. And with this, we can check whether we have to change something. Sometimes this is useful for adding some categories that were not in ESCO, but our users have. This dashboard helps for improving the taxonomy and telling and knowing how we have to expand our ground truth to help the model to improve. So with this, we count that we are able to normalize more than 90% of all the entries in our database with high confidence. So we're very happy about that. And so to sum up, the normalization workflow works like this. We build our ground truth, we train a model, we test whether the model is better than the one that we had in production before. If it is better, we put it into production and we check it with the dashboard whether it's working well or not. From time to time, we look at the dashboard, we see the weak points of the model, and we improve the ground truth for improving the weak points of the model, and we train again, and we go on and on improving the model. If when checking whether the model is better than the one that we had before in production, we find that it is worse, we check whether if we have to improve the ground truth, or we have to change something in the architecture of the model, and we do some tests until we find a new model that is better than the previous one. And finally, I will explain a couple of use cases of our normalization model. First, thanks to the normalization of the job title field and other fields that we have also normalized, we have normalized the company in which one person works. We have normalized also the skills that the people and the offers have in their description. With all these normalizations, we have built a product that is called How You Match. That it's a percentage of matching between one person and the offer that the person is looking. With this, we can tell people, okay, you should apply to this because you have a great match, you have great chances to be hired. Or we can tell the people, okay, your match is very low, don't lose time with this. This has helped a lot, both candidates and users, and because for users, they can focus on the offers that they have more probability to getting hired, and for candidates and for recruiters, if they have a lot of people who doesn't match, they have to lose a lot of time rejecting resumes. So this has improved a lot. And also, another interesting thing is that now, if you in InfoJobs look, for example, to Agile Coach, before you only got results containing the exact words Agile Coach. So although those having Scrum Master, even though for our taxonomy they are synonyms, you miss them. So if you want to work as Agile Coach dash Scrum Master, you have to do two searches, one for Agile Coach, one for Scrum Master. Now, if you look for Agile Coach, we return everything that has been normalized to the Agile Coach class. So it's just one search, you get all the offers that you are interested in. And one other thing that is great here is that before, if you look, for example, to Directora de Marketing in the female form, because usually people who write offers don't write the female form in the description, you got less results looking for female words than if you looked for the male form. Now, because you get everything that has been normalized to the category, you got exactly the same. And this is also a good improvement. So this is everything.
Then, thank you, Dídac, for coming here.
Thank you.
It's quite interesting, all the process. Thank you.